Hello students, here I Pooja Garg welcome you all in my online classes for class 9th. In previous video, chapter number 1, number system, I discussed topics rational and irrational number, second topic real numbers and their decimal expansion, and I hope you understand and doing assignment questions given in these topics in video part 1. So today I will continue with the same topic, but we have another topics under this. So today we are going to discuss topic number 3, that is operation on real numbers and rationalization of denominator. So let us begin with it. So here you can observe first topic is operation on real numbers. Let a greater than 0 be a real number and n be a positive integer, then nth root of a is equals to b if b raised to the power n is equals to a and b is greater than 0 and the symbol represents radical sign. So here on the basis of this, first you see with some examples. Here n is nth root and here the symbol represents radical sign. Here we can observe under root 4 means square root of 4. So here what is n? It is 2, which is equals to 2. So if 2 square is equals to 4. Similarly, another example, cube root of 27 is 3. If 3 raised to the power 3 is 27. Same way we have one more example, fourth root of 16 is 2. And if 2 raised to the power 4 is equals to 16, etc. And many more examples we have. Now we are going to discuss some identities based on square root. Let a, b, c and d be positive real numbers. Then under root a into b is equals to root a into root b, means we can distribute this root. Second, under root a into under root a is equals to a, means if we are multiplying the same root numbers, then we get the number itself. Third, under root a by b is equals to root a divided by root b. Fourth identity is under root a plus root b bracket under root a minus root b is equals to a minus b. And you know here how you get this identity number 4. As we already discussed for the polynomials in the previous classes, that a plus b into a minus b is equals to a square minus b square. So a square means under root a square, that is a, and b square means under root b square means b. And here we have some more identities, that is identity number 5, a plus root b into a minus root b is equals to a square minus b. And again here we are using the same identity, a plus b into a minus b is equals to a square minus b square. Now the next one is under root a plus root b into root c plus root d, means here all these are different numbers. So what we'll do, we are going to use the distributive property. So here you can observe this root a we will multiply by both the digits. Same way root b will multiply by both the digits. We'll get this. Next, under root root a plus minus root b whole square. So it is equals to a plus minus 2 root ab plus b. And again here we are going to use these identities, a plus b whole square and a minus b whole square. And one more we have under root a plus under root a, means what you are observing here, this root numbers we have same, so we can add. Now here you see some more examples based on this. The very first example is root 2 plus root 2. It means it is 2 root 2. Second, root 5 root 3 minus 2 root 3 is equals to 3 root 3. Third, root 2 plus 2 root 2 plus root 3. Now you can observe we can add these first two terms because they are having same root numbers. So it becomes 3 root 2 plus root 3. Fourth, root 5 into root 5 is 5. And if I see the next example, root 5 into 2 root 3, here we can multiply these root numbers. 5 3s are 15, means root 15 into 2. Now one more example I have. Here I use the distributive property, you just look. Now I want to discuss one more example with you people. See this example. Under root 8 plus root 2. Will you able to add these? Right now it seems to be impossible, but yes, we can. Solve it further. Here you can observe root 8 means square root of 8. So can we find the square root of 8? So you see, if I'll find the prime factors of 8, 2, 4, here means under root 8 I can rewrite it as 2 into 2 into 2. So here we can rewrite it as 2 under root 2 means can I replace this root 8 by 2 root 2? Yes. Plus under root 2. Now can we solve these two numbers? Yes, because their root numbers are same. So finally what we get? 3 root 2. So in this way we can simplify many more examples. Now the next one is rationalization. You know what is rationalization? It is a process by which radical in the denominator of an algebraic fractions are eliminated. Means we have to remove the radical sign from the denominator. You know why we need to remove the radical sign from the denominator? Because it is very difficult to show it on a number line. So now the next one is rationalizing factor. A factor of multiplication by which rationalization is done is called rationalizing factor. Here we have some example how to find the rationalizing factor. So very first is 1 upon root 2. So here what is the denominator part? It's root 2. So here the rationalizing factor is root 2 only. So what we need to do? We need to multiply and divide by the rationalizing factor. So here root 2 divided by root 2. So here what we get? Root 2 into 1 is root 2. Root 2 into root 2 is 2. So we can rewrite 1 upon root 2 as root 2 upon 2. So you can see here we removed the radical sign from the denominator. Now the second example, 1 upon 2 plus root 3. So here the rationalizing factor, we have to change the sign of it. So means rationalizing factor is 2 minus root 3. Again what we need to do? We need to multiply and divide with the same. So here if I'll multiply, what we get? 2 minus root 3 upon, here again I am going to use identity number 5 which we have studied. So 2 square means 4, root 3 square means 3. So what do I get? 2 minus root 3. So here we can write as 1 upon 2 plus root 3 as 2 minus root 3. And here we have one more example. You just observe and try to do it. Now based on this topic, I hope you will be able to do this assignment questions. The very first is you have to try to do exercise number 1.5 from your textbook. And I have given you some more questions and you can try it at your home. I request you to note down these questions. And hope you people are preparing notes regularly from these videos. Thank you all for listening and supporting me. Don't forget to like and subscribe my videos.